so one of the most fascinating things for me always is the journey that somebody takes to where they are today, right? So when I was looking at your background, I found two anomalies. Well, I would say one anomaly that really intrigued me, and that was you have a background in liberal arts, and then you went on to do a PhD in computer science, and then you had a great stint at Cockroach Labs before founded Materialize. So these are two fields that I don't really see coming together often on paper. So what happened there? Like, how did you decide to do liberal arts, and what fascinated you there, and then from there into computer science?
So I grew up in India, and as with many people who grew up in India, I was very focused on math, science, and engineering. Right. So this is not an uncommon phenomenon growing up in India. I sort of had a violent rejection of that uh, as the pressure mounted, and as I got closer and closer to college, and I was sort of looking around for, hey, what else could I be doing with my life? And that's sort of how I discovered that liberal arts colleges even existed, and was extremely drawn to that sort of broad-based education. So I ended up at Williams College in Western Massachusetts. That was sort of that was the first time I came to America. And I loved it. I absolutely loved it. But there was sort of in the back of my mind, um, the sort of guilt that. So I took a computer science class just to sort of keep that at bay, right? And little did I know, because at that point, I did not really have an understanding that computer science was like a rigorous academic field with a lot of deep theoretical structure. To me, it was like, well, like I need to make sure that I can get a job as in the software programming mines, digging code. I didn't really understand. And I found myself completely captivated by theoretical computer science, algorithms, and sort of all of the mathematical structure that there was to computer science. That was really when I really first discovered that computer science was a as an academic field as opposed to software engineering as a practice. And so it was one of many things that I studied. I really enjoyed studying history, economics, philosophy, math. And at the end of that, or towards the end of that journey, rather, um, I felt the pull of saying like, well, I wish I could go deeper, and I hadn't gone deep enough. And that's one of the things that you'll find pretty common amongst liberal arts students is, um, the breadth is nice, but it does come at an opportunity cost of the depth. And that's how I decided to do a PhD in computer science,
Right.
because at that point I'd gotten pretty sucked in and wanted to go deeper. I considered a few different ways to do that. The subfields that I found most interesting were networking, architecture, or microprocessors, and the hardware aspect of
Right.
computer science. Not quite all the way into electrical engineering and sort of fabrication, but sort of um, the design and the compilers aspect
Right.
of getting as close to the wire without getting all into solid state in physics, and operating systems and databases. And ultimately, I went to Penn for a PhD, sort of to work with a professor who was dabbling in networking and in operating systems and distributed systems, and got into distributed systems more sort of as an accident of the projects, the specific projects that he was working on that I found myself drawn to. Um, and when I was studying distributed systems, the recurring theme that I was getting, and this was in the early 2010s,
Right.
was that the distributed systems people seemed to be rediscovering a lot of things that were originally discovered 2 decades prior by the database people.
Right.
And that's how I sort of got sucked into databases as what I felt was the principled way that had the most sort of historical depth to. And so it's sort of long-winded story, but that there you
It's
have
a
it.
great story. It's a great story. So what was like? So growing up, you didn't have any specific, computer science interest in college, or so. What was your subject in
I wanted to
school?
be a theoretical physicist, so that was very much through I was very captivated by physics.
Yeah.
I it seemed to have a lot of the sort of answer, or it seemed to be the field that was asking the deep questions, right? Like, what is the nature of the universe? Like, uh,
Yeah.
things like that. And so I was very captivated by physics. I think part of that was just a little, I don't want to say out of date, but I definitely feel that physics was, say, the middle of the 20th century,
Right.
pushing the envelope on asking sort of fundamental,
Interesting
deep
questions. Yeah.
existential questions. Um, and it's only when I realized that there was a thing like theoretical computer science that was asking fundamental questions around the nature of computation, and even creating some sort of theoretical rigor around even defining what that even is, that I felt that, you know, I maybe posit now that theoretical computer science is the field that is asking a similar level of deep question around sort of the nature of existence and the
Right.
universe.
No, I mean, I wouldn't disagree, but the one thing I wanted to say was like, that's one thing in common because I wanted to be a theoretical physicist too. And I love physics, like the whole idea of existential questions and nature of quantum. And I really thought about that. But then growing up in India, I mean, there were two fields that we naturally had to pick. Either you went into the sciences or you went into becoming like somebody in a doctor or something, right? So we had
Yes.
that, what do you pick, so physics or doing something with physics was not as much as, that I wasn't aware of what I could do after I do physics. So that led me into
Right.
software.
I think one way to phrase it, it was very much you were forced to think about very directly applicable or directly career applicable fields,
Yeah.
and we both had a draw to the theoretical, more philosophical fields, and the one that
Oh yeah.
the first one was physics.
Yes, yeah. I mean, you won't believe it, like, or like, I've been following a lot of stuff that is happening in the field of physics, right? Like in my free time, like last week, I was reading and watching a video on quantum entanglement, and especially fascinated by Elon starting a new company called XAI, whose purpose is to understand the nature of the universe, right? So physics and technology and computer science, I think there's a good intertwining of those ideas. So it's fascinating.
Yes, I will plead the fifth on anything related to
Related
Elon,
to
but
Elon.
yes.
Well, let's take it at that face value, right? So interestingly, once you finish your PhD, I was Cockroach really kind of stumbled, came upon in a way as an interesting proposition for you to kind of pursue, and you joined the early Cockroach Labs team at that time, and had a significant contribution to a lot of things that kind of set the foundation for our company. So how did Cockroach Labs kind of arrive? How did you decide to do that right after your PhD?
So, maybe it makes sense to talk a little bit about the research agenda that I
Oh
did during
yeah.
my PhD, because it's pretty. I was researching security and privacy aspects of distributed data, and as part of this, sort of spent a lot of time just talking or researching and reading about distributed data platforms and architectures that were around, right? And in 2012, one of the papers that really caught my eye was the Spanner paper, because
Right.
prior to Spanner, a lot of the zeitgeist in the research field as well as in the applied field. So you rewind the clock to the late 2000s, 2010. It was all, the data is getting big. Everything was big data, right? So everyone's talking about big data. The data is too big to fit on a
Right.
single machine. Therefore, you have to go to multi-machine.
Right.
And multi-machine computation, it's too expensive to give users the abstraction layer or the look and feel of the single machine experience. It's easy to work in a single machine, or because there's only one sort of single threading. now under the hood it may be multi-threaded, but you can give this illusion of a single thread, and that's easy to reason about. But when you go to a multi-machine, the latencies are so much larger that it's too expensive to maintain that illusion, and
Right.
users and programmers just have to grow up and deal with the fact that they have to manually deal with weak isolation, weak consistency. They just like, you can't give them SQL anymore. They
Right.
have to get good at working with lower level primitives. And that was very much the zeitgeist of all the systems that were being built at the time. And the
Right.
Spanner paper sort of came back with a emphatic no. You can have both of these things. You can
Right.
have strong consistency and good performance at these massive scales. Here's how we did it at Google. And it was extremely refreshing to me because I had grown convinced that the difficulty of working with weak isolation and weakly consistent systems was
Right.
just such a massive tax on productivity of any sort, and no one was getting much value out of these gigantic systems that you had to essentially, what I would describe now as, you had to build the top half of a database like you were on your own, right? You
Yeah.
go
Yeah. Yeah.
build all the parts of the
You're right.
database that you need as a distributed system software engineering team. And so the Spanner paper in 2012 was a huge moment for the industry in general, that sort of started to swing that back. And I was very much interested in working on a system or place. I had decided around then that I did not want to stay an academic.
Right.
I love my PhD. This is there's some folks who love their PhD so much they want to stay in academia forever. There's some people who hate it enough that they want to leave academia forever. And I feel like it's underrepresented the group that I was in, which is, I really enjoyed my time
Right.
in academia. And I also knew pretty quickly that I didn't want to stay. I
Mm.
was learning a lot, but I viewed it as a time in which I was learning about a lot of amazing systems. I was very excited to then take that knowledge and then apply it.
Right.
So I was pretty set on getting a job in the software industry with all of this newfound knowledge. And I was very much looking for a spanner style take on things. What I didn't expect to find, which I ended up finding in Cockroach, was quite literally a spanner based database,
Database. Yeah.
sort of explicitly building an open source version of Spanner at the time. When I joined Cockroach, it was about, I want to say, 20 people, and it was pre-revenue, pre-everything, right? Like, the system
Yeah.
didn't even really work. It was crashing all the time, and all the tests were failing. So it was actually an extremely painful time to learn to be part of a software engineering team.
Yeah.
But it was really fun as well.
I have dug up some old blogs where I think the company was pretty transparent about, hey, we're trying to run this database for 24 hours. We just want to get it up for 24 hours. And it was fascinating for me to, 'cause when I was researching Cockroach Labs, trying to get into the company, I was trying to understand the culture. And sometimes you don't get the culture when you have conversation, but rather by what the company has produced in material and documentation. So when I went and read some blogs, and I felt like there was this brutal honesty in some of the
Yes.
blogs, which I was like, this is fascinating. And I was coming from a company that was basically Cassandra based, right? Like, so to going back to your point of view of, no consistency, Cassandra kind of came out at a time where it was solving a particular problem, but there was no consistency. And the abstraction, you couldn't do so many things. Like, there was no joins, there are no can't do simple things that a developer wants to do on a SQL database. You can't do it on Cassandra. So that was a different era. 2012, you have Hadoop, Hive, Pig, all these different projects kind of growing. And then 2017-18 is to the time you were mentioning, right? I was thinking it's very interesting that the brutal honesty at Cockroach Labs about what the system they were trying to build was pretty interesting. So you came into that time of the company.
Yeah, and that was very foundational for me in learning how to be brutally honest, and the sort of compounding value that is gained and the trust when you are brutally honest.
Right.
We very much tried to maintain that. I'm jumping ahead to Materialize, but we've very
Yeah.
much tried to maintain that ethos at Materialize because I think it worked really well
Right.
in building trust. I remember we would write. I think I know the blog post you were talking about where we said we wanted to keep a 3 node system
For
up
up for
for
24 hours. Yeah.
24 hours, and there was certainly some spicy comments on Hacker News about, call yourself a database company. 24 hours is like so pathetic.
Yes.
What are these people doing? And there was enough vitriol there that there were some folks, some more seasoned industry veterans who ended up um, responding, being like, they're actually going about this in a very mature way, because it is very difficult and it takes years and years to stabilize any kind of big data system.
Right.
And what they're doing is being transparent about the journey, because every system has to go through this, and it was very validating to see sort of the hate and the love at
Right.
the same time, and really convinced me there was a lot of value to doing this transparently, because the reality is the experienced people, you can't bullshit them. Like, they know that it's hard and it's going to take this long. So you might as well focus on them and earning their trust,
Yeah.
as opposed to faking it. Like, I think there's this instinct for when you're doing something really hard to sort of fake it till you make it, or like try and pretend to be like, because
Right.
it's super intimidating because the industry heavyweight is Oracle, and they've been around for 50 years and they're
Yeah.
super mature. And so you think maybe in a sale I have to sort of try and look as mature as I am, but it's like, it, one, you're not going to win that fight, because
Yeah.
it doesn't matter how mature you seem. You're not 50 years old with billions of dollars of free cash flow, right? Like, that's
Right.
just not who you are. Um, you need to win the trust of the people who have the specific set of problems for which the decision in their mind is build versus buy.
Yeah.
Because if they're just buying a database out of the box, they're going with the tried and true. Like, you've already lost those customers. You have to focus on the people for whom um, their only reasonable alternative is building an in-house system, which is going to be less mature than, because that's effectively a database project that's
Yeah.
6 months mature. So now you actually have an advantage in being a couple of years mature. So you might as well just talk about all the bugs you've solved, and essentially being transparent about those bugs is the best way to win those people over, because they're going to
100%.
read that and be like, oh man, if I'm going to build my own system, I'm going to have to solve all of these problems. And
Yeah.
I'd rather not.
Yeah. No, I mean, it's fascinating the way you're saying this. It's truly, significant that what people don't understand what it takes to start a company. I mean, there are lots of startups that see value feedback and revenue kind of come really quickly. But I think my opinion is database space is particularly difficult for startups, because it takes time before you start paying cash flow, right? And you spend so much money on R&D, and you really have to have a different approach. And I think that's what Cockroach Labs and Materialize to. From my research, you have, as you were saying, that ethos of carrying that transparency to your investors, to the people who are going to use your products that you're bringing. So from that point, let's dive into Materialize. Did you always feel deep down inside that you were going to co-found a company at some point in your life?
So it was definitely a possibility and something that I was reading about and sort of trying
Right.
to keep educated. I knew I wanted to work at sort of a small company. I very much would have been very happy working at Cockroach or working at a small startup and growing with that. One of the other papers that I had come across during my PhD after the Spanner paper was actually, it's the same sort of conference circuit. Spanner was the best paper in 2012. This was the best paper in 2013. So
13. Okay.
literally the next year was this research out of this research group from Microsoft Research, called Naiad, a streaming system. And again, you have to rewind the clock a little bit, but back then streaming was in its absolute infancy. And for most streaming systems at the time were very limited in the amount of complex computation they could do and the amount of state they could manage, and update. And so, if you were using a streaming system in earlier than 2010, you had to make these pretty strong, pretty severe compromises in the expressivity of the computation that you could express in the streaming system. So
Right.
you, on one hand, you had these batch systems like Hadoop or so, in which you could scale out quite dramatically, and you could express a lot of complex computation in sort of multi-stage pipelines and things like that. And then and of course it would take hours and hours, if not a day. And if you wanted something lower latency, you had to like severely restrict the kind of, you could maintain some counts, and you could uh, not do very much more than that. And it turns out
Right.
you can do a lot of things by just maintaining a bunch of counts and cleverly sort of doing some algebra at the end. But it's very different. You had no hope of doing a streaming join, right? Like
Right.
streaming joins were just not a thing. Um, and enter Naiad, this paper that basically built a stream processor that was fully capable of doing everything that contemporary and batch processors could do.
Right.
And you got the streaming kind of for free. Like it was one of these things that gracefully degraded into a batch system at absolutely no cost to the expressivity of the queries. It was, outperforming batch systems at batch computation at batch queries, and outperforming streaming systems at streaming queries. It was really, it was like, hey, there's no trade off. This
Right.
is a stateful, scale out stream processor. And I remember reading it, being like, well, like half of the research I've been reading about is now obsolete.
Right.
um, I remember I was a pretty argumentative grad student. Maybe that already comes through here. I don't know. But, I remember going to my advisor being like, why are we reading this other junk? It's obsolete. They should, like,
Right.
their entire line of research is superseded by, effectively 10 lines on top of Naiad. Like, we should stop building. At the time, there was a lot of bespoke systems. Graph computation
Right.
was one of the um, research areas where I felt had been completely superseded by Naiad.
Right.
And I remember contacting the lead researcher on the Naiad project, Frank McSherry, who is my co-founder at Materialize now, but back then just this industry um, stalwart researcher, and you know seeing if he had an internship spot, and turns out he did not at the time. And so, in the back of my mind, I always really loved that research project. I remember telling him, "Hey, you should commercialize your research project. Maybe you want to take a look at what these people are doing at Berkeley, because going back, same group of research community in 2011, the best paper at a different conference, but same sort of related field, was the Apache Spark people who had
Yep.
won the best
I
paper
remember that
for
one. Yeah.
Apache Spark. And I was like, hey, these guys are starting a company. It's funded by Andreessen Horowitz. It's like pretty cool. If you have you considered doing something like that? You know, if you are, let me know, because I'd love to sort of work there. I'd love to. Where can I put in my application? They're just sort of like, I assumed he was going to commercialize Naiad.
Yeah.
And he wasn't. He had no interest whatsoever. It was like, why would I do that? I just won best paper. Like, I'm done. Or, like, he was very much under the academic sort of influence of, the thing to do is to publish more
Just
papers and win
publish
more
it.
awards.
Yeah. Yeah.
And, and then the rest will just sort of follow, because obviously everyone's reading these papers. And I was like, no, like, no one, that you have to do that yourself. And I remember this like tremendous disconnect between the two of us when we met at a conference.
Right.
And so I was sort of waiting for him to do something, and he wasn't doing anything. Eventually, in 2014 or 15, I forget, Microsoft Research went through this huge shift in. They shut down the research lab in Silicon Valley. They downsized some of the other research labs. Um, because nothing was coming out of Microsoft Research that was commercially moving the bottom line for Microsoft. It was very
Right.
much operating like the Xerox PARC, um,
Model. Yeah.
yeah, where like it was disconnected from the commercial aspects of the parent company. And I don't know, it was, soon after Satya Nadella became CEO, and
Mhm.
I don't know what happened
I'll
up
ask him when I
there.
get him on the podcast.
But Microsoft Research was clearly, marked as a
Like a
as
dead projects kind of thing. So yeah,
or not sufficiently tied into the overall strategy and
got
needed
it.
to be
Yeah,
sort of brought in and more closely tied to the product teams, and maybe who knows, right? So
yeah,
it's in a much better place now, where it's sort of very core tied to many of the AI
AI
projects
stuff.
that
Yeah,
they are doing commercially. But Frank ended up leaving Microsoft and working on building an open source version of his uh, stream processor called Timely Data Flow. And
yeah,
by this point, I was working at Cockroach, and then we reconnected when I, reached out and I was like, "Hey, I'm excited about this Timely Data Flow thing that you're doing on your own." Many of the other members of the NIAD project ended up just working at other companies like Google. Many of them ended up being um, members of the TensorFlow team, which is which was also a distributed sort of
yeah. The
computing.
yeah the AI stuff, GPU processing and stuff like that. Yeah.
And that was when I think I really made an impression on Frank to take commercialization seriously.
Hmm.
And I think I was also able to tell a more coherent story, because I was able to say, "Hey, here's what Cockroach does. Here's how Cockroach builds a commercial product. Here's what it looks like. Here's how they market. Here's how
Right.
they transparently share um, how difficult it is to build a commercial product. Here's the kind of people that work there." Frank came, had dinner with the Cockroach co-founders, like walked around the office, and I think that was when it became a little more concrete in his brain,
Right.
being like, "Oh, this is like this is a
Like a viable
this could be nice."
opportunity.
Yeah.
So it's interesting when you were sharing. First of all, it's fascinating to hear the story, right? Like just how that. So it's been interesting because your time at Cockroach Labs gave you some of the perspective on what it takes to start a company, and especially have smart people to work with, and also have a perspective on what a go-to market might look like. And that knowledge is what you shared with Frank, and just at dinner and coming together kind of helped you begin Materialize.
Yes, and I want to make clear that that wasn't just me. That was
Okay.
very much the Cockroach co-founders were very generous with their time.
Right.
They sat down with Frank as well. Spencer, in particular, the CEO of Cockroach, spent a lot of time, not just at one-on-one with me, but also at all hands meetings, sort of being very open and transparent about the financials, the fundraising, we'd have the literal bank balance like up every week on the on one of the slides, the you know the latest customer meetings, like what people were saying in these customer meetings when they thought Cockroach would be ready. And that gave me a lot of and also one-on-one, he would just very much tell me,
Right.
um, and I was very open about my interest in starting a company, so he would occasionally pull me in, be like, like, "I'm gonna have this meeting, and this is a distraction for you now, but you should come, because this it's you should see how the sausage is made, because it'll be
Oh
useful for
wow.
you later." Which is like a wonderful
Exactly. I was thinking like this
mentor
is
who
yeah.
went out of his way to make it easy for me to sort of do this.
I mean, that's fascinating. I mean, I'm just knowing that. Like, I know Spencer. I've spoken to him a few times. He's all obviously very generous with the way he talks and very humble. But at the same time, I doing that is an extra effort, and inspiring someone else to do something, which is very inspiring. Overall, when
Yes.
I look at it, it's fantastic. So right after that, you chose and decided that okay, we got to do Materialize. You start Materialize. So, what was the specific problem that you felt, Materialize needed to exist to solve for users? That you looked at the market and you felt this needs to be done. So
Yeah, and it's interesting because that's how it sort of foreshadowed. That's how we ended up at the name Materialize, right?
Materialize,
So
okay,
back then, it was the stream processing technology that was way, way, way differentiated in its capabilities to do low latency stream processing. And of course, there's a few companies, mostly in Silicon Valley, who do stream processing at scale, right? But if you take it as a fraction of the companies that do any sort of analytics at all, it's a small fraction, right?
right,
So the companies that have complex analytics, if you take that as a market, that's like 50, 100 billion dollars of spend a year. If you take the companies that are doing complex stream processing at scale, I mean, that's probably, some single digit percent of that
Right.
in terms of spend, because stream processing is horrendously complex. And
It is
so we
complex.
felt that the need, if it was easy enough to do streaming as it was to do large scale batch processing, a lot more people would be doing it. Like an
Right.
order of magnitude more people would be doing it. Most of the limitation is that it's it requires an extreme amount of talent, which is very constrained, and resources, because you essentially have to staff up, like, it's like minimum sort of ante to play this game is like 10 to 20 big data stream processing engineers, right?
Yeah.
And like you can't pull it off less than that. And like how many companies have the scale and the resources? And so it's like, the companies that have mature stream processing, uh no surprise, it's Uber, it's Netflix, and it's like five other companies like this.
Right.
And a company that doesn't have that level of by the way, it's also very much constrained to Silicon Valley, right? So
Yeah.
even
Yeah.
say a company like Walmart that has a lot of cutting edge technology, they have a Silicon Valley Walmart Labs.
Right.
And so geographically, it's also constrained to folks who are able to open an office in like a tech hub,
Right.
right?
Right.
And we felt that if it was a technology that was more accessible, you could get ubiquitous adoption, because you know everybody who competes with these set of people also wants these capabilities, because it's just moves the bottom line.
Right.
And very quickly we settled on what this meant for us. Meant that it had to be SQL, right? The language in which people express computations, that is the most widespread language, is SQL.
Mhm.
So anybody this had to be accessible to anybody who wrote SQL analytics queries, right? And when we wrote that out, we realized that the simplest way to communicate this to um, people who are maybe new to streaming was, these are materialized views that stay always up to date, right? Like you don't want to build and maintain the stream processor that does the incremental computation to keep the materialized view up to date. You want to be able to access some cloud service,
Right.
hook up your data pipelines, and say, here's my data sources, they change. Here's the query. I want the answer to this query to always be as up to date as possible. That is the extent to which I want to, you know, care about the problem. Or some people might care to go deeper, but it has to be accessible to somebody who's willing to restrict themselves from going any deeper.
Right.
And that was when we decided to just name the company Materialize, right? It's like, what does it do? It materializes views over all kinds of changing data.
Right.
And it, it's sort of a good hook to sort of make very clear what our mission is.
Right. No, I mean it's a great name. I like the name because what I was trying to do when I was researching Materialize, I would put Materialize, and every time Materialize view would pop up. So
Yeah.
so fundamentally,
And also part of it, a reaction to the cockroach name. I'm not gonna lie, that one, not my favorite. Try to. I'm sure you've experienced this. I had to explain to my mom that I was after my PhD going to work at Cockroach Labs. She had a fit about this, so I took
so
a.
it's funny that you brought it up, especially Indian moms and Indian parents. I told my parents, they didn't care about it. I was like, okay, you're doing
Huh?
something, that's fine. But I had to tell my father-in-law about it, and he was particularly like upset about it, because at the time I also had like I had a big offer from another big company, and I was like, hey, you know what, I don't want that, it's a very well-known name. I'm going to pick something called Cockroach. And my father-in-law was like, did I get my girl married to the right guy? So we had
Yeah.
that kind of a moment, but I had to explain to him what the company does without even uh, without breaking his brain. So that's funny.
Yeah,
uh,
my mom was just very upset that it wasn't Google. She was
yeah.
like, and I was trying to explain to her, the founders spent 10 years at Google. Like
Yeah.
it's got a good, set of people, but just the
Yeah.
name was
I-
very
it's
much
it's it's funny that because the other offer I had was from Google actually, and my father-in-law was like, "What?" But I think what I saw where I was in my career at the time, like I felt like I needed to come to a place and work with really inspiring leadership and a great set of people. Like that's why when I spoke to Cockroach and I looked at the product and everything about brutal honesty, about the way they brought things up, especially the sales engineering team that we had was like, or what we have right now is fantastic, right? So that's the environment I wanted to come in, and that's why. So it was not something of a do I want to go to Google, but more like where do I want to go, right? That kind of thing. And so I can see what led you to do this, right? So I just wanted to go back to what you were just mentioning with Materialize, right? Like it's a great name, obviously. What were the other systems who have been in the market that you were looking at that time? I know I've used, like I use a lot of Spark in my career, right? And Spark streaming was a thing, but the way Spark streaming worked, where it had resilient distributed database and it would just split stuff up in memory processing, and it was worked great. And then you also have I think projects like Flink and Kafka had a project, and then they brought Kafka's KSQL streaming, but they did it differently. I think they used I believe a RocksDB engine, if I'm not wrong. But your approach is bringing timely data flow and build Materialize architecturally in a different way, right? So what got in when you were trying to design? Were you looking at these systems, and then
Yes.
what
S-
and how that all came about? Yeah.
So yeah, this is an excellent question because many of the architectural decisions in Materialize are different to some of these other systems
Right.
and more in line with traditional databases than you would think. Particularly, Naiad was very much at the time a reaction to the Spark. Naiad was there was a predecessor system at Microsoft Research called Dryad,
Okay.
um, and Dryad Link. If you're familiar with Link, the Microsoft
Yes.
ORM, like it's to me, I love SQL and we've chosen SQL, but if there's like a fantasy world in which like there was a second query language, Link, LINQ,
Yeah.
was the most beautiful ergonomic thing. It died, of course.
Right.
It was part of the .NET platform, and so its fate was very much tied to sort of .NET adoption, which
It kind of died down. Yeah, I remember that. I've read some stuff about it, and even attempts to revive it, but I don't think it kind of encapsulated
yeah,
into turning
that's
something.
that's
So,
what I'm hoping, my keeping my fingers crossed for, is the sort of second coming of Link, because
like,
that
yeah,
then I will be very
maybe
happy.
10 years.
But but anyway, Dryad Link was actually a predecessor system to Spark and did a lot of the interesting architectural innovations come from Dryad Link. The Microsoft research team then moved on to Dryad, but Dryad Link very much had this RDD esque uh, framework of having large scale batches of work that were scheduled out on distributed systems by a centralized scheduler, right?
Right.
So
Yeah.
Spark also works this way. There's a scheduler,
Yeah.
and the scheduler sends work items. So it says you computer, like, first we'll shard the data set, right? So we have some data set A. Let's break it up into chunks that are manageable by a single machine, and then let's assign these chunks out to the resources that we have. This is also how Hadoop worked, right? And this is why you had Yarn and all these, essentially schedulers.
Right.
It was much, let's schedule work. How do we schedule work efficiently? The centralized scheduler sends work out, and then that machine, when it finishes the first step of the data pipeline and computes the result on its shard, it then notifies the scheduler, and the scheduler sends it the next batch of work. Or sometimes these outputs have to be shuffled around, right?
Right.
So
Yeah.
the
Which
output
is
of
which is a big
one
problem. The shuffling is a big, intensive thing. I hated that. So, but yeah, go ahead.
So
Sorry.
most of the bottleneck in these systems is the shuffle, right?
Yeah.
Because it essentially imposes this global interlock where all the machines are sort of seized up waiting for the work to be shuffled because they need it before they can begin their next
Yeah.
work. And then you have all this problem where like one straggler or like one failed machine is holding up 90 other machines that are just sort of waiting for it to get done, but then actually it's failed and now you got to reschedule the work. And most of the performance problems for anyone who's worked in this sort of world is around that, right? There's another problem though, which is if you want lower latency or if you want some intermediate outputs, one approach you can take is what's called micro batching, which is you just make the batches smaller
Right.
and so you can get more frequent results. The problem with this is, if you think about it, as you scale down the batch size, the amount of work that the scheduler has to do explodes. And the scheduler becomes the bottleneck because if you divide something in 100 chunks, you got 100 things to schedule. But if you want a micro batch, you divide things into 10,000 chunks, then you got 10,000 pieces of things to schedule,
The
right?
schedule. Yeah.
And there's sort of a bottleneck beyond which you can't micro batch further. And the sort of uh, the Neo and the Matrix realization is, the only way past this is to stop scheduling, right? Like you
Yes.
can't have a centralized scheduler. Like there is no spoon. Like we got to figure out a way to do this without a centralized scheduler. And um, data flow computation is very much the aspect of we're going to fix the pipeline in place. We're going to break up this pipeline across many machines. We're going to shard, but individual processors are not going to wait to be told what to do next. They already know what to do next. They just have to wait for the data, right? So
Right.
the interlock is around getting the data. But if you have all the data that you want, you don't wait for the scheduler to tell you to do the next unit of work. You just do the next unit of work and move
Right.
on. And now you have you remove the centralized scheduler from the bottleneck. And this is sort of the NIAD slash data flow slash Flink way of doing things, right?
Right.
Um, by this point, Databricks has moved on from Spark microbatching. So Spark streaming, the V1 of
Yeah.
streaming at Databricks, was this microbatch approach. They now have a new thing called Spark structured streaming, which is a data flow oriented
Kind of
stream
a process.
processing.
Yeah.
Um, there's further observations that the NIAD team had made once you get into data flow scheduling, which is state management. How do we manage state? So being good at state management is very important for doing complex queries because if you take a simple query like a sum, a streaming sum, there's not much state because you always have to remember one piece of information, which is I've summed up a bunch of values. I have the current running sum. When the next thing comes in, I'll add it to my running sum, and then I can throw away the other piece. So even if you've got terabytes of input streaming through, at any point you're only maintaining one
One
large
state. Yeah.
integer
Yeah.
worth of data. Not every computation is this simple. So if you take and this is the one that tripped up everybody, which is how do you do the streaming join? Because if you have two streams coming in where you can join any input from the left stream to anything in the right stream, you need to have a index representation of the right stream that you can look up. And
Yeah.
the early attempts at solving this, particularly in the Kafka ecosystem, were to limit your joins to a window of time. So you say, I can join something from the left against the last 10,000 things on the right. But what this means is the join condition is now restricted into something that is correlated temporally between what's going on in these streams, which is a very complex um,
It's a very
thing to
complex
even
idea.
like
Yeah.
and so you can easily trip yourself up on this because what happens with some data that comes late? Oh, it's missed its window for joining. Okay, now what do we do to the results of the computation? Do we throw it out? Sometimes you can, but not always, right? And the thing that fundamentally NIAD solved with like a giant sledgehammer was it was very good at maintaining gigantic amounts of state, right? And if you can maintain gigantic amounts of state, efficiently at low latency as the state is stream as the streams are going through, then you can express arbitrary computations. Now, my takeaway from all of this was if you can express arbitrary computations, you can now express SQL. And now people can just write the SQL queries that they wanted to write, and they can just forget about all of this, right?
Yeah.
And that's the sort of dream of Materialize is you make this accessible to folks who never, you know, want to worry about, you know, state management.
Right.
there are other systems that, for instance, Flink, you can store a lot of state on RocksDB, right? Um, that ends up being pretty scalable when you want to scale up, but it sort of imposes a minimum amount of resources that you need to use. So it doesn't actually scale down very
Mm,
well.
mm,
So it sort of requires, it only sort of pencils out when you have terabytes and terabytes of state. So it works well for the Netflixes of the world who have terabytes and terabytes of streams and state. It doesn't tend to work for business logic for commercial businesses that do not have telemetry data from 1 billion devices across the
right,
globe, right? So this is another thing that the recurring pattern is: things that work for fang scale companies, or the technologies that work for the fang scale companies, are not oftentimes the right technologies for what I'll call mainstream American businesses,
right,
because the scale that they operate at is unique. It is several orders of magnitude higher, and so they are making trade-offs that are going to pencil out because they're at that scale that aren't going to pencil out. And I think
right.
this is something Snowflake brilliantly understood, right? So Snowflake, I think, is the company that solved most of the problems for the most number of businesses um, in the world, and probably doesn't solve
Big problems.
data analytics at Google scale, nor
Yes.
do they want to.
That's a good way to put that, because when I was researching, I was trying to understand what would be a good correlation. So I feel like what you're trying to do is what Snowflake did for batch processing, but what you're trying to do for streaming. Is that a good way to like
That
put
is
it?
that is that is how we think about it
Okay,
internally. Like, we
got it.
want to be Snowflake for streaming. We think
Streaming. Yeah,
similarly, a lot of people wanted to do analytics and they couldn't until Snowflake came around, and now they can do batch analytics. And similarly, there are a lot of people who want to do streaming, but today are limited by the architectures that are available to them. And we want to be a similar solution that allows them to do streaming in the cloud.
fascinating. No, I mean, the paper that you were talking about, I actually found that paper when I was researching. So for folks who are listening, I would say go. I haven't been able to read it, but I did find it. I had read the initial extract of it, which is the timely data flow paper from Microsoft in 2013. I think Frank McSherry is one of the collaborators who's also the founder with you at Materialize. Very good.
Yes.
So I wanted to dive into, because you were talking and we were hinting on the architecture. I know recently you have looked at the architecture. You have a great background in distributed systems. So the way the architecture right now is, you have compute and storage separated, and you have the arrange layer, or the layer that connects to the compute layer or storage layer, which is the SQL layer, and then you have multiple sources. So for all the folks who are listening, who want to start, or who may have a need to start using Materialize, how do you express that architecture to them, and how did that architecture come about in terms of breaking it up, having S3, all those things?
So it's a great question, and I'd love to sort of just go deep into architecture, because just like,
Yeah, yeah, let's do
that's
that.
the name of the podcast, right? So um, the first thing about S3 is, well, one, it's very cheap, and not everyone knows that it's very cheap. It's the cheapest way to store your data.
Right,
Um, you're not really going to find a lower total cost of storing stuff than an S3, but it's also extremely high bandwidth to read from. Um, and you can have multiple readers. So it allows you to use that as a separation layer. So you can have multiple consumers consuming from a single shared storage without having to copy all that data all around. So it is where we keep all of the data at rest, right? So
right,
if you connect the data, so first of all, Materialize, as with any streaming system, you got to connect it to some source of changing data, which typically is an OLTP database, right? So where is your data landing? Where's the first class place where it's landing? It's an OLTP database like
right.
Cockroach or Postgres, or and you might have a mature architecture where you're feeding that through Kafka to use that as a way to separate your systems, right? So Kafka is a wonderful system for decoupling your
Yes.
various systems that have data, right? So Cockroach natively outputs data to Kafka, change data capture,
Yeah.
as do many other databases. We also support just reading directly from Postgres, because a lot of people with Postgres who want this, who don't have Kafka yet. We also have people who have Postgres who use Debezium to do change data capture in a Kafka. But anyway, all of that
Right.
data, you've got data in motion. It needs to land into Materialize. So first thing we do is we have these data sources, right, which are clusters of compute that can read your changing data, and save it to S3 permanently, durably, right? This is very important. The thing that our sources do is this data that is coming to us may or may not have timestamps that we can trust.
Right.
So it's coming from Postgres. There are timestamps that we can trust in the form of the log sequence number, right?
Right.
So Postgres has durable log sequence numbers that are guaranteed not to change, the time at which the transaction took effect. Um, the Actually, it's not the time at which the transaction took effect; is the time at which it was written to the log. But then there's
Right.
also the transaction ID that is the time at which it takes. So
Right.
you have a ordered sequence that is trustworthy. Kafka, you don't have this, right? So a Kafka a partition, a single partition of Kafka does have an offset that goes up and down, but you do not have an ordering guarantee between
That's
partitions. And
true. That's not available.
if you're running Kafka at scale using multi-partition, so there's sort of a question of in what order did these events actually happen. The first thing our sources do is they assign a durable order and then write that down to S3. At this point onwards, we can guarantee serializable isolation for queries, because if you have two different views over this data, we want to give you the correctness guarantee that these things align with each other, right? So
Right.
if any non-determinism is made deterministic at this point, we may have to make an arbitrary choice. Or if you give us enough metadata, we will respect that choice that you've already made.
Right.
Um, and so our sources are very much a necessary component of all our downstream correctness guarantees.
Got it. So if I can
So we
ask a
write all that down to S3. Yeah, sorry, go on. Yes.
so if I can ask a question, just so one of the most critical things you're doing is to make sure that for consistency, which is important, is the durability built into the sources that you're doing when you're reading and storing it into S3. So that's like I would say, like a recipe that you have cooked into Materialize, right? Because
Yes,
that's important.
correct. And we actually use CockroachDB for that, because
Okay.
CockroachDB is the scalable metadata layer that allows us to do this across. You may have hundreds of sources,
Right.
right? And then you care about the order between all of these sources, because you may later join these sources together,
Right.
right? And CockroachDB, Snowflake uses Foundation DB for a similar purpose, which is it's the scalable metadata layer that is the sort of on which all the consistency guarantees are based on top of,
Right.
right? We use Cockroach. Well, we knew it well. So that was one advantage it had. But really, you need a database that has serializable guarantees. And realistically, there are only really two. There's only Foundation DB and Cockroach DB that
Kind of
are
give you that.
pretty
Yeah.
battle tested at scale at serializable isolation. You could use a serializable single node database, but then that has its own scaling limits. Or you could use Zookeeper, right? So those
Yeah.
are the but
Which is also
those are sort
kind
of
of a
your options.
nightmare to manage. Which-
Yes,
yeah.
which is what we didn't want to get into.
Yes, yeah. So I know I cut you off from the stream of thought you had. Why don't you go back to that architectural completion that? Because I felt
Oh,
like that was a
sure, yeah.
very because I felt like need to bring that up because that's a very important recipe that you've cooked into to guarantee consistency for folks who are going to use. So I wanted to kind of highlight that too. So yeah, please go ahead.
Thank you. No, once the data has been durably recorded into S3,
Right,
it can be used by different units of compute. We call these units of compute clusters, but if you're a Snowflake user, you can think of it as a virtual warehouse.
right,
So you may be an organization and you may have lots of different people. They want isolation guarantees, because they may have, someone may have a P1 use case that cannot go down. Somebody else may have a P3 use case, and then there may be an intern, you know,
doing
typing
stuff.
like a monkey on a typewriter, right? Like crashing all the time. And these people all want guarantees from each other, right?
Right,
So um, what you do is you spin up a cluster, just like in Snowflake, you spin up a virtual warehouse. This cluster can reference any of the data that from any of the sources. Now, you
Right.
have role-based access control to decide on a policy level if some sources are special or not. But in architecturally, you have access to all of these sources that can come in. And inside these cluster is what I call a cluster could be a multi-node thing, right?
Right.
It's a logically isolated unit. This runs a timely data flow scale out um, unit of computation, right? And this, so if you spin up a 3XL cluster, you'll get 4 machines. If you spin up 4XL cluster, you'll get 8 machines, etc. You get all the benefits of scale out compute that you want, that can reference any of those sources. And then you define, that one, you interact with SQL. You say, create. You can just run a select query that'll spin
Right.
up a transient data flow, compute the result, or you can type create materialized view that will create this data flow that is long lived, which will then write the results of that materialized view back through a different S3 collection, right?
Right.
Which can be, again, referenced and used by downstream users, right? So you might
Right.
have, say, a data services team, a centralized platform team that creates and maintains a bunch of enriched materialized views that join
Right.
across and a whole bunch of data sources, and then create these curated collections that are used, say, by a serving team that is serving this as part of a live application. And they might want different levels of replication. And by the way, all these clusters, each individual cluster can be replicated to whatever sort of replication unit you
Right.
need. And you have sort of isolation, compute level isolation, that if somebody else's cluster goes down, your cluster is completely unaffected.
Right. Well, that's awesome. It's fascinating to know when folks are trying to build these systems. I mean, you have to think about how compute works. You have to think about how storage works, and then you also have to start thinking about, okay, that intern, what will he do, and then build systems like that. And it's fascinating when when I was listening to you, that as a company, when you're building systems, you have to consider all these different folks and different events and use cases when you're building a system. It's not as easy as, hey, we need to solve that problem. And I'm also very glad that you brought up the idea that it's not the big problems that big companies are trying to solve. We have to solve problems for a lot of other people who are also trying to solve regular problems, everyday events, and things like that. That materializes kind of going after. So, which is really great. When I was, thinking about, some of the things that you do and my history of using Spark, we used to have transformation, then we have to do an action. Like we basically run a bunch of things through RDDs, and then you drive the actual action, which is a count or some sort of an aggregate function in the end, right? But what I have had in my life, in my career, I'm fascinated by data, right? And I haven't had any role in my career where I have not interacted with data. So the whole idea of being able to take the data, to wrangle it to my needs, and to get value out of that, it's not something that just I do. There are so many people who are trying to do that, and I see one of the biggest value props that you have with Materialize is the join capability, right? The ability to take an OLTP database and a table there, and you have a Spark, not a Spark topic, but like a Kafka topic where you have some data. You're able to bring that together and build a materialized view on top of that, and then have that accessible to complete a data story, right? So
Right.
that was just my understanding from my research. Do I have the complete picture? Why don't you maybe
Yeah,
expand
I
that a
think I
little bit
think
more?
very much
Yeah.
Materialize is consciously designed for organizations, right?
Yeah.
Materialize is a platform for organizations, and organizations definitionally have a bunch of different people who have a bunch of different responsibilities.
Right.
And a single system that is built for a single team is not going to be enough. Timely data flow is actually enough for a single team, right? Like that's an open source project.
Right.
You can build and run, and people do deploy this in production to compute large scale things, right?
Right.
And that's great, but it's not for an organization. It's a single unit of shared compute that if you installed one bad data flow in, you could crash the whole cluster. Building products for organizations is requires having to care about all of these other isolation and sort of guarantees against not because they're malicious, right? But because they have different objectives.
Right. Yeah. So when you were saying that, I was thinking about the fact that when you're building it for organizations, you have to consider different use cases, right? So what kind of use cases are you saying people adopt, Materialize for? Of course, we're not talking about a big scale companies like Netflix or Google trying to use that, or Uber using it, or Twitter even using it. But rather, we're talking about some specific use cases that you have seen that have surprised you. So tell me about some use cases that Materialize solves, and also some use cases where you saw, oh, that's a surprising way of kind of using Materialize. Tell me about that, if you have any
Yeah.
experience. Yeah.
Yeah. So we have a customer, a Fortune 500 company that is deploying Materialize to um, they have many factories. These factories have assembly lines where they build products, and they are trying to get real time alerts to their assembly line engineers. Because the assembly line engineers have an idea of, hey, if this thing happens and this thing happens, I need to know immediately.
Right.
Because they in their manufacturing process they have a tremendous amount of input waste, so they hundreds of millions of dollars of inputs that get wasted for 30 minutes while some machine somewhere else is spinning producing output when really it should have been stopped because that intermediate output can go no further in the line, right?
Right.
So um, they currently have these alerts in a batch system. The batch system is too slow, and as a result, they waste hundreds of millions of dollars worth of product
Wow.
per year, and they want to move that batch system alerts to streaming. Now, that batch system is 20-30 years worth of SQL queries that are running on prem that are built in a crude up, it's 30-40 lines of you know common table expression SQL.
Hmm.
And so it's not trivial to understand or even port, right?
Right.
So they need a system like Materialize so that they can port that as faithfully as it exists today, and then get to seconds of latency end to
Got
end
it.
to when they hit that alert on the screen, uh, so that they can take action sooner. So that is so that's a use case that I personally love because
Yeah.
it's saving people money. We also have a customer, a fintech company, using us to uh, reduce to catch and identify fraud, because with financial fraud, typically the fraudsters know they have a limited window of time to
Right.
steal as much money as possible. And so this is a very straightforward, from when we have the input signals that we've modeled out in batch. And they use Snowflake. So they've got all of these things modeled out in Snowflake, which is typically for an analytics journey. You want to start in batch, right? Like
Right.
you're just trying to understand what's going on. It's like, here's our historical performance, here's the signals we had at the time, and I'm going to sort of you have a data science team or a data analytics team that's sort of playing around building these models. And then eventually go, you know what? When we know this and this, we need to shut that thing down like
Right.
immediately. Moving that to production for most companies involves going to the production team saying, hey, can you build this feature that when you know this and you know this, take this action? But then the data model that you have in your batch might rely on inputs that are coming from two different databases
Right.
upstream in and can't be joined against each other in a trivial fashion. So now you're talking about a multi-quarter process to build out and implement
Oh
that
yeah.
feature, and most features die at that point, right?
Yeah.
And so they're using Materialize to move that from batch to streaming so that they can
I
take
mean, that's good.
action when that fraud.
I mean, that's good because I wouldn't want a fraud to happen and me taking a decision like half an hour later, right? So you want
Yes.
the fraud use cases to happen more as real time as is possible within the limitations that we have available to us, right? So I mean, that's a pretty good use case. I was good. I was thinking when you were saying that one of the most interesting things that that has been throughout this conversation that is very evident is that you haven't changed anything when it comes to how a user interacts with the solution that you have with Materialize, which is more fascinating because if you go back to India, even today, we are still studying SQL. Every university in the US, everywhere around the world, SQL is not going to go away as the language of how you interact with data. So it's great that you've brought that SQL layer and have kept that, rather than going to a fashion of document, the way you interact as a JSON or something, which is, even though it's fascinating for web applications, I don't think is like the right language for data. So what are your
One
thoughts
thing I
around
love
that?
about
Yeah.
SQL is, well, one is you got to meet people where they are. You got to build software for the what people already know, and more importantly, interacts with the systems they already have, because
Right.
people are not going to, let's say we built this most amazing data system and we sort of take it out to market. People are not going to react by saying, voila, like, all right, let me just throw out all of my other stuff and start from scratch with your
Right.
system. Like, your system has to live in an ecosystem that has a dozen other tools and technologies. Like, there's a BI layer, there's
Right.
a data integration layer, there's a lineage, there's governance, there's, and all of these systems and tools speak SQL,
Right.
right? So how are you going to build a parallel and unfortunately streaming has for a while been the sort of parallel set of tools that is divorced from the mainstream set of tools, which is why you need to build and staff a completely separate team.
Right.
So that was very much what we wanted to avoid. We wanted to take this to the mainstream companies that had not yet had the luxury of building and staffing a streaming team. That said, that doesn't mean I don't, late at night fantasize about a world in which,
You could do
Link
link.
wins.
So one of the questions I want to ask is for folks who are listening, and of course we've had a great conversation looking at the architecture, some of the decisions that you've taken in building Materialize the way it is. What is your advice to data teams who are going to start using Materialize? Like, how should they look at Materialize in a very simple way, to look at those problems they solve for them?
So Materialize is built for those data teams that are thinking about going to streaming for the very first time, right? So
Got it.
it is, in my view, the easiest way to get started with streaming. It meets you where you are. If you are familiar with a data warehouse or a cloud data warehouse, Materialize should feel very intuitive and approachable as a way to get started with streaming. You should be able to get up and running and getting and get streaming results in just a single day.
Right. That's awesome.
The most annoying part will be connecting up your sources of data.
Yes.
That's always the most annoying part of
So,
using any data tool.
expand on the sources right now. I know you have a Kafka connector right now, and you also
We
have,
will
I
pull
believe,
data.
from Postgres.
Yeah,
Yeah.
we
What
will
else?
pull data from Postgres, so we
Okay.
connect directly, and from your upstream Postgres's database, we look like a read replica. So it's like, hey,
Gotcha.
I'm a new read replica that showed up, and I wish to subscribe to your log of transactions.
Nice.
Every Postgres database has the ability to support this because it supports read replication, or we pull data from Kafka. Right.
Got it.
So if you already have a Kafka cluster, we can connect to that and pull data immediately. We're looking to expand this over time. So, ultimately we can pull data from wherever it is, right? So
Got it.
today, Postgres and Kafka are the supported options.
So, are you open sourcing any of those elements? So, other folks who are trying to kind of working on making an open connector that allows other systems and teams to kind of build connectors to Materialize. As has that been a thought?
So we view Kafka as that ecosystem, and
Okay.
it's an ecosystem that Kafka does very, very well. So
Right.
we're partners with Confluent, that has a wonderful connector ecosystem, but also the open source Kafka ecosystem as well. Some of our customers use Confluent, some of our customers use just open source or Amazon managed Kafka.
Got it.
We will connect to your streaming data, whatever flavor of Kafka it is.
Got it. Yeah, it makes sense. I mean, they're leading the pack too, so that ecosystem is already kind of built out, and you kind of that you're leveraging that in a way too, right? So that's great.
Yeah, we want to be a downstream system for building analytics and sophisticated applications that have a real-time data component. We have no desire to replace Kafka.
Yeah, very cool. So I was thinking, like, when you were sharing that, when I asked you, hey, what does a data team do? And you had this perfect 30-second pitch. So I was like, hey, there's a co-founder and a CEO, you know? So I want to, as we close, it's your story is really inspiring. I mean, I have to say that, not also being a fellow Indian, right? It's always great to meet
Thank you very
other
much.
CEOs. So how has the transition been to being a CEO from being, I would say, a researcher or a doctorate, of that subject? How has that been for you?
I would say I feel like I went in as eyes wide open as possible, mostly due to the help and transparency of Spencer, right? So he
All right.
very much opened the can of worms and showed me sort of, I guess mixing some metaphors here, but sort of pulled up the rug and showed me all the stuff under the rug and said, you ready for this?
Yeah.
And sort of I had to I had a nice long think about that and sort of opted in saying, you know what, like I am. So, fundraising, financing, how to pitch, how to be, how the behind the scenes management, board management, uh, all of these aspects of starting and running a company. I feel very lucky that I, got to see all of that before taking the plunge, and so
Right.
I sort of did it on an opt-in basis.
That's good. Yeah. And so, now as a CEO, right? What are the few things that we can expect coming out from Materialize going into the second half of this year and going into next year? What are you working on that's really exciting and cooking? So
So, I will drop a teaser here. We have some very, very exciting announcements coming out in September. We
right.
will be at Kafka Current, the conference
Nice.
in the fall, as well as DBT Coalesce. We have a lot of exciting announcements this fall. So if you're interested in staying up to date, go to materialize.com. We have a newsletter and a blog that you can subscribe to. We have some big announcements coming. I'll just leave you with a teaser there
Hey, if this
today.
podcast does breaking news, I mean, come on, I will take that, right? No, thank you so much for kind of sharing that. I mean, for me, it's been fascinating, like going in, learning a little bit more about Materialize and having you on the podcast, right? And I always ask this question because, and especially in your case, it's truly inspiring because now you're a CEO. You moved from India, which is like leaving behind family and friends and building something new in in a country, learning, interacting with new people. So for students, not just in India but around the world, what's your advice to folks who are trying to kind of lean in? What would be your one, twos, and threes? I mean, you don't have to give all three. Maybe a couple of advice to folks who are trying to get on that path. So
On the path to
to become an engineer or to become a CEO somewhere down the line. Yeah.
I think being an engineer is a solid start. I didn't sort of want to become a CEO, until much later. I wanted to become an engineer. It was only after I'd been an engineer and found out that I'm kind of a mediocre engineer that
Right.
I was looking for a
That's
different
pretty
job.
humble of you. I
um,
might have to go check the code and then kind of rate you on that, but I'll take it.
um, the what has worked for me has been sort of back to the early or the earliest question about liberal arts is getting a broad education in things other than just the your major, right? So a lot of the skills that I need to make use of today are things that I acquired in, for instance, clear writing and communication,
Right,
right? I think that that's not something that is in the main curriculum of a computer science major. Nevertheless, there are other classes that emphasize that, and
right,
it is you are going to really or at least I very much appreciate that I had the opportunity to study those. I would say um, studying it, and I don't want to be prescriptive,
Yeah.
right? About, you have to study history and economics.
Right.
Those are the two that worked for me. But my point is more studying three or four different things and synthesizing those together ends up being extremely valuable. So I would try and stay broad for as long as possible.
Right. Oh, that's awesome. I think what you shared and your journey is like a pretty interesting contradiction, right? In a way that to what people believe that I have to focus on a particular major and just dive into that, and I will learn everything that I need to learn about life. But I think when I just unraveling what you have kind of shared is like there is a lot more space to acquire knowledge that can lead you to an interesting position in life. So that's always good to know. All right. So I just want to say with that, we will end the podcast, Arjun. I mean, again, I am truly honored to have you on the podcast. And, I'm going to follow Materialize very closely. And also see, bring that up in conversations with people I speak to. Definitely a company that is doing some exciting stuff.
Thank you so much for having me. It was really fun for me as well.